So, I've got something really interesting for you today. We're diving into a syllabus from a modern engineering college. It's got all the stuff you'd expect, right? Advanced math, physics, coding. But there's also this one mandatory course on knowledge that's literally thousands of years old. Let's figure out why. Jen, isn't it? Why would an institute that's all about the future make its students look thousands of years into the past? What's the end game here? Well, let's find out.
Well, the answer actually starts right there in the course description. And you'll see pretty quickly, this isn't just about history for history's sake. They have a very specific, very modern goal in mind.
And there it is, straight from the syllabus. It's not about nostalgia. The key word here is relevance. The whole point is to draw a direct line from India's incredible intellectual heritage to the problems that engineers are trying to solve right now, today. And when you look at the course objectives, you see how deep this goes. We're not just talking about reading old texts. Students have to actually analyze the scientific principles behind these traditions, figure out how they connect to modern tech, and really grasp India's massive influence on the world. It's all about going from history to application. So what exactly are these students digging into? The course is split into 6 main units. Let's do a quick flyby of this ancient body of knowledge. First up, the absolute bedrock of any engineering program, math. But we're going way, way back, long before calculators, to explore the ideas that made all of our modern computation even possible. And this is where it gets really mind-blowing. We're looking at concepts that are fundamental to pretty much everything we do: the decimal system, the value of pi, and of course, the idea of zero. These weren't just theories, they were complete game changers. The course even gets into geometry from things called the Silva Sutras, which were ancient manuals for building altars, but they contain some incredibly complex geometric rules. Okay, so from pure math, the course then looks up to the stars and how those numbers were used to understand the cosmos, astronomy. You gotta understand, ancient astronomy wasn't just about stargazing for fun. It was an intensely practical science. If you wanted to create an accurate calendar for farming or for festivals, you had to understand solar and lunar motions. It was basically the timekeeping technology of its day. All right, so from observing the world, the course shifts to how people shaped it, focusing on architecture and the engineering of whole cities. And wow, this is where you really see some early civil engineering genius. The syllabus talks about Vastu Shastra, these traditional texts on architecture, but also the town planning of the Harappan cities. We're talking advanced water management and grid layouts thousands of years ago. It just shows this incredible skill for solving urban problems that, frankly, we're still dealing with today. Next, the course literally digs into the materials that built this ancient world, the science of metallurgy. And what's crazy here is just how sophisticated it was. This wasn't just banging on metal. The syllabus covers the creation of Wootz steel, a crucible steel so incredibly strong and flexible that people all over the world wanted it for centuries to make legendary swords. From hard metals, we switched to soft materials. But trust me, the technology here is no less impressive. For thousands of years, Indian textiles were a cornerstone of global trade. You have to think of it like a massive technological and economic engine. The course dives into the complex weaving and natural dyeing techniques that made these fabrics famous all over the world. And finally, our little tour wraps up with the science that underpins everything else: agriculture. What's really cool here is the focus on sustainability. The syllabus looks at these amazing systems like the Aries in South India, this huge complex network of man-made lakes for irrigation and other rainwater harvesting methods. It just shows a deep, deep understanding of managing resources in a way that works with the environment, not against it. Okay, so that was a fascinating tour, right? But the big question is still hanging there. How does studying ancient irrigation or metallurgy actually make someone a better engineer in the 21st century? This, my friends, is where the syllabus gets really clever. You see, the course is designed like a journey or a ladder. You start by just remembering the facts, but then you have to understand the science behind them. And here are the crucial steps: apply and analyze. Students are actually challenged to take these old methods and think about how they might solve modern problems. Now, this chart might look a little academic, but stick with me because this is the absolute key to the whole thing. On the left, you have course outcomes. That's what you learn in this class. On the right, program outcomes. Those are the core skills every single engineer needs. And look,
The course explicitly connects applying traditional methods to the modern skill of problem analysis. It's a direct bridge. Let me translate that for you. This course isn't just a history lesson. It's meant to be a kind of mental gym. By analyzing how ancient innovators solved really complex problems, often with limited tools, these students are training themselves to be more flexible, more creative thinkers when they face their own engineering challenges.
So at the end of the day, the whole idea is to build better engineers by giving them a much wider perspective. It's about helping them understand that innovation isn't some new invention, and that brilliant ideas can be found anywhere, even deep in the past.
And that leaves us with a pretty powerful question to think about, doesn't it? In our constant rush to build the next new thing, we're always looking forward. But maybe, just maybe, some of the most elegant solutions to the toughest problems of our future are just waiting to be rediscovered in the wisdom of our past.